present on the bleeding edge of databases.
Hey guys, hello, thanks for coming back. This is going to be a developer-focused session. This morning I focused more at a level for business decision makers, so you're going to see some code, you're going to see some smoke and fast databases, and hopefully that'll be okay with you. So let's get going. So, let's see if I can see here. Okay, sure. So, announcement for the people in the back. Can you just, can you stand rather than sitting because the credenza is weak?
That's very weak, yeah. We don't want you to fall down.
We do have a chair up here for someone.
Oh, okay.
Folks.
Okay, thank you.
So,
Okay, ready to go? Okay. So this morning, I'm assuming all of you saw the keynote, so I'm going to go fast through the slides. It's an expanded deck, and the deck is on my site, Langit.com, so you can get it. The reason we're all here is this unstructured data explosion, and we're hearing about a lot of NoSQL solutions and Hadoop, but I wanted to broaden that and show you some of the bleeding edge databases that I've been working with. And I showed you some business problems that caused me to think about these kind of databases. And the first one was live tweets on a building or live textual information streaming very, very rapidly, maybe like the soccer information. So you have this fire hose. So you need a database that is going to be able to contain this and work at an incredibly fast scale. And the database that I talked about this morning was one called Aerospike. So I'll just remind you that Aerospike is designed to be real-time NoSQL, flash optimized, in memory, exponentially scalable. They've had multiple benchmarks, independent, prove them up at 1 million transactions per second for reads and 40,000 on one server for writes, and this is on a single server. They have ACID compliance, which is really super interesting, and tunable consistency. And this is some other earlier benchmarks on Aerospike 2, and you can see how this compares to some of the other popular NoSQL solutions, which aren't bad products. It's just for this particular business problem, this kind of a solution is, in my opinion, an interesting solution, one that you should take a look at. And I do have the specifics on here showing a 4-node cluster, and it shows how much CPU, how much SSD, so on and so forth. And this is all publicly available information, so you can validate the results. So let's get into it. So what I did, because I thought it would be fun, is even though Aerospike can be installed locally, they have a community edition that you can go out and grab after this presentation that's free forever. I wanted to put it up onto a cloud because I thought to evaluate the overhead of these systems, it would be interesting if I used like the same vendor cloud. And everybody uses Amazon, which is certainly a valid choice. And if you're comfortable with the Amazon cloud, super. But a cloud I've been doing a lot of work on is the Google Cloud. So my instance, and this is the dashboard of Aerospike, is up on the Google Cloud, and Google is kind of the new game in town, and one of the reasons that I wanted to share what Google has with this audience is because I've been a trusted tester for the Google Compute Engine, their virtual machines, since inception, so over a year, and I've been stunned by their performance. So for big data scenarios, I think that looking at GCE instances should be in all of our sort of toolkits. So to that end, before I even show Aerospike, I'm actually going to show you live, and I do have a wire, okay, but how quickly an instance spins up. So if I click New Instance, and you can do this, of course, through a command line, but I'll just do it through the console. And I haven't heard him see. And here are the different just types of instances. I'll just pick standard. And then I'm going to choose an image, and those of you that have good eyes, notice that you can get your typical Linux instances, and you also now can get Windows, which is sort of interesting. So I'm just going to pick the typical sort of instance, and I'm just going to click Create, and it's 256, and we'll just see how quick this instance becomes available that I can SSH into it. And I would predict, based on my experience with this will be less than a minute that this instance will become available. Now, I have found that as an architect in big data scenarios, the fact that the GDC instances spin up so quickly and are so powerful and, frankly, so cheap, they have a big free tier, there it is already. So that took less than 1 minute. Oh, and it's in Europe, too, because I didn't bother to put it in the United States. So it's pretty stunning how fast these things spin up. So I built my Aerospike up onto instance 1, and when I want to connect to it, all I'm going to do is I'm going to SSH into it. So I'm just going to use the Google utility, which is GCUtil. And I'm assuming that most of you are new to the Google Cloud. Is anybody in here using the Google Cloud? Yeah, like one person. Okay, so they have a set of utilities that are command lines. So you go gcloud, auth, login, and then you're going to be redirected for your authentication. And this is all well documented in their SDK. And then you can use the GCUtil to SSH on in. And then I'm going to go ahead and paste. And now I'm connected. And now I can run the Aerospike utilities from this console just for testing. Now Aerospike is a pretty built-out infrastructure. They have JDK, a Java developer user kit, pretty well documented, which you can explore at your leisure. I thought just for today we'd use the command line because it's a little bit quicker to see. So we're going to use the ACLI command line. Now in order to do that, I'm just going to alias it out, and then we can explore their data store and kind of see how you work with it, basically. So I'm just going to alias this out. Command line demo is super exciting, right? And then go here and alias this out. It's the ACLI tool. And then I can just call it, and this is from their own documentation, but just to make it quick, the basic way that you work with this is a wide column store. So I'm going to use a put. Can you guys read that?
No.
Aerospike is a database. So I installed the Aerospike database on top of Debian. So good question.
You can make the font a little bigger, that would be good.
Okay, great. So now I did a put, and I don't know, can I? Let's see, I don't know. Command plus, thank you. Command plus. How's that? Yay, huh? Oh, yay, okay. So I did a put. Good audience feedback. And now I'm going to just do a validation that the put worked. And inside of there, I have success. And now I'm going to get it back out and just retrieve it back out. So it's a very simple interface, and there I get it back out. Now, in addition to that, you can use the query language, AQL. So there I'm using AQL, and the concepts inside of Aerospike are namespaces. So namespaces, oops, I can type. And there are some sample ones, and then sets within the namespace, and then bins. So for a SQL person like me, it actually isn't too bad. So because it's SQL-like, which actually is something that I consider very much when I look at these new SQL implementations, because for those of us that have been in the enterprise world for a long time, there I'm doing an insert, okay, and then I can do a select star from, and it's going to be test.demo. So you have a level of, there's 91 rows. You have a level of familiarity in working with the thing that is important. It's very important. It's an important decision point when I'm looking at these NoSQL and NewSQL systems. How mature are they? What are their interfaces like? What is the tooling like? You can actually use it, okay? In addition to this, you also have the console. And so here's the console, and you can see inside of here, this is for monitoring. It's for swapping your number of nodes. You can expand on the fly. So it's purely an admin console, but just to show you that this is the sort of live thing. If I go here to definitions, and I go into demo, I don't know if you guys can see that, but there's the 91 items in the demo set that I just queried. So working with Aerospike has been pretty painless, I have to say, and the fact that the performance is pretty stunning with the 1 million transactions per second has me doing POCs for customers. So one of the reasons I included it in the presentation is because I'm actually working with customers now on some potential POCs because of the ingestion more than anything else. So some of the other implementation details about Aerospike, this is more validation on that. This is the architecture. There's a client and a server piece. So if you are going to try it out, make sure that you read the install, and Aerospike will be happy to work with you on it because the install, frankly, could be a little bit easier. And then there's an architecture example of how an Aerospike implementation could fit into an architecture. This happens to be a shopping example, and we are at being hosted by some people who do shopping type activities. So the idea is ingestion point, fast ingestion point. And there's a look at the Java code with the AQL Eclipse plugin, which I did play around at home, but I kind of ran out of time. Pretty easy. Again, so I gave these guys a very high score on usability, which is really important for these newcomers into the market. And then there's some things with the console, the live upgrade, so it's an admin style console. And if you guys are interested in trying it out, you can try it out for free. So this is one that I would heartily recommend that you go and you take a look at, Aerospike. All right? We're going to go to the next one.
So what are the typical business cases that you use?
The typical business cases for Aerospike are, Aerospike itself means like the tip of a rocket. And I think if you think of it that way, that is the kind of a business case. So the tweet wall that I showed, so you have you're displaying the tweets for the Super Bowl on the side of the stadium. You are the lead architect. You want to have a system that can spike up and down as needed, pretty seamlessly and at a relatively reasonable cost because of the capacity on the server. So spiky traffic that you're going to do a lot of reading and not, in my opinion, very complex querying. You're just going to sort of simply pull it out. You notice I didn't talk about fancy aggregations, ML scenarios, that kind of stuff. You're sitting on the front, ingesting, and just doing sort of simple queries out of it. Does that make sense? Okay, good. All right, next one. So the next one is a different kind of data. So my next scenario is not so much a huge amount of data coming in, but a huge amount of complexity of the data that you're working with. And this comes with Semantic Web, Web 3.0, the Linked Open Data project. And what I'm doing here is I'm doing some work with a company that has a very interesting store. This is a live picture of the linked open data. So what this is representing is this is semantics that can be understood across. So graph at scale is another way to think of it. So if you're not familiar, DBpedia is the data making the Wikipedia into a database through semantics and sort of at the center of the world. And Data Hub is a site that helps to provide metadata around linked open data. And in addition to that, they also have endpoints, so you can query and start to play with this data. And since I know you're going to ask me a use case of this, there are many, but one that I've recently encountered is linked open data for public art museums. So data that's in the public domain that is related amongst different public entities and then presented by the various entities to add value to their offering. There's this huge effort that's occurring. This man in Southern California actually is the leader of it. So the way this data works, if you're totally new like I was to RDF data, it uses this query language called SPARQL. And you have a SPARQL endpoint. And again, it's kind of SQL-like. Okay, what was that? Command plus? So you guys can see it? Look, see, I learned. Okay. So here you're querying DBpedia, and you have the idea of a triple store. So it's like English. A little fun fact about me, I actually am not a math major or a computer science major or any of that. I'm a linguistics major. So that's why all these languagey things kind of work for me. So the idea here is subject, predicate, object. So graph, again. So this is an example of a SPARQL query. Select distinct concept where there's a group of concepts and you want to have 100 coming back from DBpedia. And now, can I do minus? Oh, okay, and I can run the query. And there's my list of DBpedia high-level values. So this is a really, really simple SPARQL query. And SPARQL queries, as you might think, looking at this, can get super, super complicated. So is there something out there that can deal with that? Yes. And what is that thing? That thing is called AlgebraixData. So AlgebraixData is a product, or they have a product, it's called the SPARQL Server, so it's a database, and it's built natively to process complex data with a mathematical engine. They have, if you saw the keynote this morning, like 12 patents, and mathematicians are their founders. So math is their secret sauce. And the idea is their queries will have, they'll be learned basically because it's the mathematical components are reused more easily than parts of database queries. And it's designed right now to work with a triple store with RDF. What's interesting about their implementation is that's the direction that they built out, but because their core offering is the engine, there is an opportunity and a possibility to build out for other languages and other types of data. So their product is the engine. They've gotten super good results, 1 billion triples on one node, and it's interesting because they can scale up and scale down. So they're really about Internet of Things. And their direction is to run on commodity hardware again, so that they can go all the way down into sensor devices and all the way up, to run 1 billion triples if need be. So they're W3C and OGC compliant. It's a SPARQL semantic database. If you're new to SPARQL like I was, there's a O'Reilly book called Learn SPARQL that's really well written. And natively built, proprietary technology, their patents, runs on commodity hardware, scale up, scale down. They have had amazing benchmarks. There's a TPC benchmarking group, and they were the only people, I think I put it in here, there's the 1 billion. Yeah, they were the only RDF database to even complete, I think it was 12 out of the 17 benchmark queries. All the rest of them timed out. So they've taken this really interesting approach to this problem that was previously not solvable at this scale, and that approach is math, basically. So for these guys, what I did is they are pre-product, but they are going beta July 1st. And just for you guys, I got them to put a thing on their site that you can sign up to be part of their beta if you wish to. But what I did for you guys is I created an instance in Windows on Google Compute Engine because it's my favorite VM to play with. So there it is. There's my Windows instance. And you can see, oh, here, you probably can't see. So you can see I'm running US Central and I'm running Windows. And of course I don't SSH into this, and it's 172.255.120, whatever. I RDP into it. So there it is. And I can't seem to make this bigger. Okay. All right, so anyway, so here it is. So to start it up, I just turn on the SPARQL Server. Now they're not as built out as Aerospike because they're pre-product, if you will. They have some actual customers, NDA customers, can't say who they are, they're big people, big companies. But their product is their engine at this point. They're actually looking to engage with the developer community and partners to build sort of out around their engine. So if any of you are kind of inclined that way, they would be interested in hearing from you as well. So what they use to demonstrate is an open source tool. So be clear on this. This is not like what they consider their client tool. This is a free RDF tool called Flint. It just happens to stick on the top of their engine. So you can actually see how to get in and get out of it. So the way this works is you have to first load some data. So I will do that. And I'm going to go ahead and load 100,000 triples. And so I just click on this. It's a weird interface. I say okay, and there I'm doing my file copy, and I'll submit. And there's my file. I think it ran. Let me just make sure it ran. Yep, there it ran. So it has 100,000 triples, and now I can go back and query it. And then what they have in this setup is they have the 17 benchmark queries that are used for RDF data stores so that you can run them against this. So they basically allow you to rerun the benchmark on any hardware. So inside of here, I'm going to go ahead and load this first query, and if you're not familiar with SPARQL, I don't know if you guys can read this, so I'll just say select a year where, for the journal, the RDF type is bench journal, and then the DC title is journal 1, and then it is issued in give me the year. This is like a smoke test. It's a really simple query, just to make sure that your server is running, and then that's the results that we expect, and of course you can output in different formats, because that's just kind of the way these things work. So we can do XML, and then we can do JSON as well. And we can go on, and we can go on. I'll go up to the query 4, because that's a more complicated query, just to give you a sense of what SPARQL can do, because the point of this thing is complexity at scale. So you just click on it and say OK. And so here, you're loading a bunch of, these are ontologies, or basically kind of like data dictionaries in a way, if you're not familiar with this. And then you're selecting some distinct values, and then here's your where with a filter clause. Now we're only limiting the results to 10 just because we don't want to have a huge amount of load. And we're going to go ahead and run this, and it comes back nearly instantly. So it's a pretty simple sort of interface in. The tricky part with this, and I know you guys, some of you have a lot of mathematical background, so if you do set up with these guys, they also have a more complex set of queries over here. So I'll just go ahead and load those. And again, loading 100,000 triples just by clicking here. Just curiously, while I'm doing this, does anybody actually use RDF databases right now? What do you use it for?
Just experimentation.
Yeah.
But does this do reasoning?
It can.
It can.
Again, the core product is the engine. It depends on what you put. I'll show you what the architecture looks like. So this is to give you an idea of a more complicated, you got optional clauses, you've got all kinds of gnarly stuff in here in terms of SPARQL. And their idea is just to show, oops, well, of course now I'm not connected somehow, is just to show how much more complicated this is. So I'm going to go ahead and go out of here, and let me turn this SPARQL. So this is funny. This shows pre-product. You know how you stop this? QH. Quit hard. I thought that was fun. Anyway, such a nerd, right? Okay, so another reason I run this stuff on the Google Cloud is because if I go back inside of here, one of the things I'm going to give you guys all is $500 worth of credit. And I don't work for Google or anything. It's just I'm a Google MVP basically, and they give it to me to give to you. So I have never gone over my $500, no matter what I've done, because it's amazing how much you can do for free on their cloud and how quick it is. So I can go inside of here, and I can look at my project, and I can see, just at a glance, what kind of overhead I have. You also have quite a lot of metrics, so it's good for benchmarking. I just really like working with the Google Cloud for benchmarking, so it's sort of an aside of this presentation. Okay. So Algebraix. The other thing is, and if you are interested, you might want to just copy this down or take a picture of it. It's demo.algebraixdata.com. If you don't feel like installing the server. What this is a demo that they've set up to explain linked data, SPARQL, how their performance improves based on their engine without revealing their proprietary information. Some of the mathematics, so some of you are math geeks and you want to have some glimpse into how this thing really works. This is a demo that you can go out and hit, so that might be helpful to you. And again, strong patent portfolio. So the SPARQL Server, oops, wrong word here, runs on any cloud or runs on premises, and it can run on a device. It can run on commodity hardware. It needs no indexes because of the way that it works, so that's really kind of interesting. And it works particularly well with sparse data, so the linked data, if you will. Self-tuning, it keeps the results and the intermediate sets, and it does support point-in-time queries because of the way it optimizes. So it's got some really interesting capabilities around complex query execution that I think lends itself well to Internet of Things. Now, Algebraix itself, the core offering is the data algebra and the platform. This part up here, they're still doing work. And again, they're looking to work with partners, they're looking to work with, verticals, that kind of stuff, because they feel very solidly around this center part, and this part right here they're looking to build out. So it's an opportunity for some of you guys in the room if you're looking to do something kind of interesting in this new data space. And again, if you want to try it out, you just go to AlgebraixData, and then here's the little link right on their homepage, and sign up for the SPARQL Server evaluation, which will become first available on July 1st. So that's Algebraix. Any questions about Algebraix before I move on? Yes?
What is the actual licensing? Is it
No idea. They don't even have pricing, so it's on an individual basis. I don't work for them anyway, so I don't
Where are they
know.
based?
They are based in San Diego for their executive offices, and their development is in Austin, Texas. All right, next thing. If you guys saw this morning, the GDAL project. So my third bleeding edge database is some people wouldn't call it bleeding edge, but since I happen to be doing a Google theme, I've been working with Google BigQuery, again, since it was internally provided to anyone who wasn't a Google employee, and I just think it's a great product and needs a little love, so I wanted to show and talk about it. And I kind of see it as a middle way between Aerospike and Algebraix, in that it doesn't have the capacity of Aerospike, it doesn't have the complexity of Algebraix, but what it does have is it has a very high capacity and a very high complexity, and has a very strong ecosystem around it and like zero setup time. So it's kind of the middle of the ground. The SQL-like language is really nearly ANSI SQL. We even have windowing functions, just to give you an idea. So if you're very fluent in SQL language, you can like go to town right away. Their query and ingestion rates, they continue to up. It's Cloud Wars, right? And Google I/O is coming, so it's probably going to be even more announcements coming up. But a couple months ago at their cloud platform event in San Francisco, they lowered ingestion prices by 85%, and they upped the ingestion rate, and basically they're just turning up the spigot and making commercially available what they have internally to kind of counteract the competition. You have OAuth, so you have access control built in, which is cool. It's a wide column store. And the idea is basically query as a service. There's a RESTful interface to it. Now, when you just are trying it out, there's a web interface, which makes it super easy, zero setup. You just go to the web interface and party on. But you normally put it, you write programmatically against it in your application. And it's part of the Google Cloud ecosystem, so you have Java, you have Python, you have Go, you have even .NET. So you have a pretty rich ecosystem of developer languages to work. And of course, the reason for being is 750 million rows in less than 10 seconds or faster. So you have to load up the data. Now, one of the things with Google BigQuery is this is a cloud-only solution. So unlike Aerospike or Algebraix, which could be on-prem or cloud, this one you have to be okay with sending your data up to Google's cloud, which for some of my customers is a deal breaker, but for some it's not. Text or JSON data, and you can have up to 1,000 K inserts per second in the streaming model now. And then, like I said, it supports the core SQL concepts, and it has some analytic SQL, which is sort of cool, like standard deviation, variance, correlation, and regex match expressions. So I think the SQL in it is pretty powerful, basically, and I find it to be very usable. And the price is pretty darn good. Query is about $5 per terabyte processed, and the storage is $30 per terabyte per month. So I use it quite a lot to just try things out when I'm doing, like, I call them the imagination around big data projects, when you just want to load up a bunch of data and query it and see if there's any value, because it's just so easy. You just put it up there and SQL query it, basically. And it seems to be something that a lot of people in this room, in this industry, don't know about. So one of the reasons I wanted to show it. This is a benchmark, independently verified by a university, running certain type of queries against BigQuery and then some of the main competitors. Some are relational, like Postgres, and some are quasi-relational, like Amazon Redshift, and BigQuery did pretty well there. So time to show it. So BigQuery is a lot of fun in that, in addition to the GDAL project, which I got to show the spinny globe because we're a big data conference, right? There is some fun queries around this site called bigquery.es. And I thought for this group, it'd just be, it's the afternoon. We have to like lighten up, right? So this is one of the data sets in BigQuery is all the GitHub information, all the GitHub commit information. So you can run this query and you can see which programming languages induce the most anger. Because here you've got a regex expression. So you can see it's, what is it? The result here was VML and then C, which that makes sense to me. So let's see. So I'm going to just go ahead and just use this query, because you get, when you create a project, let me show how it works. So you're like in the developer, well here, let me be more complete. You make a project. So Google Cloud Services, you make a new project. And once you have a new project, then inside the project, then you turn on the services. So you just turn this little button, see BigQuery, and you just say on, okay? And then once you have that, then you just go on, then you go to BigQuery, and then you have this console you can play around with. And inside of this console, you have the samples inside of here for that. Do you not have it? I thought so. Public data samples, yeah, here we go. So the public, oops, I don't want to load any. The public data samples, here we go. The GitHub, they pull it every day. So everything from GitHub, just to play around with. So there, you have two things you can do inside this console. You can do jobs, which is how you load or copy, and then you can do queries. So if I wanted to do a new query, I'm just going to be like super lazy and just paste this guy in here. So this is, I'm going against that GitHub information, and I'm basically, so do you guys agree with these words? Are these the mad words? Angry, annoyed, annoying, appalled, bitter, cranky, hating, mad. Pretty fun, right? So, yeah. Oh, okay, okay, so what did I do wrong with the query? Of course, I'm trying to be cool and I messed up. That's the way it always goes, right? So let me go back here. Did I not? I probably didn't copy it right. So let me go in here, go back. Because there's this whole list of fun things that you can do inside of here. So BigQuery categories. And GitHub. Yeah, this is the kind of things like I'm with my people, but like most normal people go out like partying or something on Saturday, I'm like, oh, look at this. This is so fun. Let me try this one, see if it works. What are the 4 most common Java repositories? 100 most active repositories. Let's see if I probably just couldn't copy, right? You go over here, and go over here, and go over here, and I'll just go compose query and see. Let's see if I can go here. So what am I doing wrong in my query here? Oh, run. Oh, duh. Thank you. Oh, it's running. Not waiting. Because, it's 9 seconds is too long to wait. So 26 gigs processed in 9 seconds. Thank you, audience, for helping me out there. So that's cool, right? Like zero setup. I like this as a big data person. This is a very useful tool. I use this like all the freaking time. So, it may not be bleeding edge, but to me, this is the kind of service that we all need to be aware of. I saw a very good presentation in this room from the guy from Data Sift, I think it was, and I was pretty impressed by that. The same type of thing that you can just quickly query on things. Because I think one of the big things that I see out there in big data projects is what I call the failure of imagination in the business layer of people. People are funding the projects. And it's not because they're bad people. It's because, we can't even keep up with the technology. How can the business people keep up with it? So part of what I do as an architect is I will use tools like this to try stuff out so that I can show, hey, this is, hey, these are the, languages that cause the most anger in GitHub or whatever it is, right? And then the business people can go, oh, I get it. And then you can go on with your project. So it's a tool set is really what it is. So BigQuery, I like it a lot.
Question.
Yes.
Where do you get those? What's the link for those sample projects?
It's right there, actually. It's big queries with the dot and the ES. I know they're really fun. They're super fun. The GitHub ones, really, really fun. Another thing about BigQuery that's like really, really cool is, like I said, it's built out around it. So there's a whole bunch of partners. You can go super simple with like Google Sheets, and you can return your information out to Google Sheets, or even Excel, which I think Google just built just to make Microsoft mad, which was really funny, actually. You have Tableau, you have QuickView, you have Vime, and I'll just show you a Vime dashboard, because that's like when I show this to executives. Let's see, where's that Vime thing? Here it is. When I show this to executives, they won't see it in a dashboard because they're used to dashboards, right? So if you take these big data scenarios and you use these tools to do quick processing to kind of chest things out, and then you show them in dashboards, well, frankly, that's how I get my big checks, because then the executives go, great, go for it. Because they can see it, is the point. So Vime is just one of them. This is a retail dashboard. And what this has got is what here? It has 457 million rows in the data set, and however many rows here. So this is about retail, right? And then you can just, it's your typical kind of dashboard, right? So you can say, okay, I care about, California or what. It just looks like a dashboard. It's just that it now, is instantly queryable to a much higher degree because it's got back-ended by BigQuery. Which really, should the executives actually care what's back-ending it? No, that's for us to worry about. But having the tools that connect to these types of things is an important aspect of any type of new database that we pick. Are we going to write the tool? Does the tool connect? Tableau is so fantastic and smart and successful because they've connected to everything. That's, you know, every one of us should have Tableau personal. Actually, we should have a Tableau license on our desktop because it's just that useful. It's, again, in that tool suite of things that we need to have. But BigQuery connects there. Okay, so how to try it out? You just set up a Google Cloud account, upload or stream data, or you can use their data and then query. So this is the one you want to take a picture of. This is cloud.google.com, and there's your code, GDE-in. And I would be like eternally grateful if you would like tweet and do cool things because, well, you know, I'm going to Google I/O in 2 weeks, and Google kind of likes this kind of thing, and Google has a lot of things, and I want a self-driving car. I just got to tell you. I'm kidding. Lynn wants a self-driving car. So I'm joking, but seriously, you might as well try it out. So
I'd like to see the ticket on that one.
I know, right? Okay, so the big thing with these new SQL databases or these new types of leading edge databases is you gotta put your hands on them. You know, that's another sort of takeaway about this. You can't try everything, so you have to say no to some things, and the things that seem the most interesting, and the way I pick them is benchmarks. Did you notice that all through my presentation? I talked about externally validated benchmarks. I get hit by so many vendors, I don't even listen to them. I just go, where's the benchmarks I can read? And once I see benchmarks, then I get interested, and then I think, okay, I'm going to try it out, and then you have to get your hands on it. I mean, that's a huge tip to you. We've got 150 now NoSQL databases. We have new SQL databases. We have, you know, the guy from this morning, 27 Hadoop distributions. It's such a confusing landscape. So I want benchmarks, and I want tools that I can try things out. That's what we, I'm assuming most of us are developers, as a developer community, need to be demanding of these database vendors, and they'll give it to you. Yeah?
How do you handle dirty data in some of these scenarios?
Oh, that's after. We'll talk about it after. Okay, and again, I'm thinking I'm at time. I have no idea, but I'm just going to get done and let the next person start. So I always have to talk about the other thing that I do. I know you heard it this morning, but you're going to hear it again. Go tell a lot of people. In all seriousness, I'm going to just take 1 minute and talk about this. Our teachers are not equipped to teach our children how to create technology, and we will not have anybody from our country who can work in the technology creation industry if we don't do something about it. Not somebody else, not Washington, not the teachers, we, us. What? Us in this room.
You want some applause on that?
My stuff, it's free, it's tested, I've taught over 1,500 kids, or you can go to school and teach whatever you love. The point is, we have to go help our schools. And I cannot be more serious about this. We have to. We have to. So please do. All right, thanks for listening. I appreciate it. Hopefully you have a good day.
All right, we're going to have a coffee break. There's a question up there in the front.
Let's go back to the slide.
We'll go back one more slide. So if you guys are interested, Scale, Southern California Linux Expo, we have a kids track, so if you'd like to help with that. All right, so we wanted to see the slide with the code.
Yeah,
okay.
More time.
There we are, so GD-in. Okay, get that down, guys. This is good stuff. So I imagine you're getting a ticket from the CHP and you're sitting in this self-driving car. So, question as people are going, do you go participate in particular meetups?